Now let's go to supported underground mining methods. Okay, so we have cut and fill stopping, where ore is mined in horizontal slices. After each slice is removed, the void is filled with waste rocks or tailings to provide support for the next slice. Okay, so they fill the voids, okay, for support. In the previous cases, they are creating natural supports. They are not doing anything to fill up the supports or to create support artificially. Okay, but from here they will be creating artificial supports, or they will be creating supports from the remaining rocks. Okay, so they are cutting a place and then they are filling it for the support. Okay, so after each slice is removed, the void is filled with waste rocks or tailings means again waste rocks to support to provide support for the next slice. High valued ore deposits like gold and silvers are mined here, provides excellent ground supports, reduces the risk of collapse, and slow and expensive due to filling. So they have to fill it. That's why it's very expensive and time consuming. I'll show you a cut and fill stopping if available. Okay. So you can see this part is still left to be mined, and this part have already been mined and then refilled by backfillings. Okay, so that it gives the support to the remaining ore body, right? So this is a fault related deposit where this block is the footfall block and this block is the hanging wall block. Okay, this is how they backfill the void created and then follow up. Okay, then we have stull stopping, which is actually vertical timber beams or stalls. So that they use like wooden planks for support. Used to support the roof of the mine, it is commonly applied to steeply dipping narrow ore bodies or local ore bodies. Local mining techniques use this type of methods where they create um, timbers or wooden pillars for support. Simple and cost effective, limited to smaller and high grade deposits. But there are high grade deposit, but this needs to be very small deposit area where they can use this timber or wooden planks. I'll show you again if I have stall stopping. So these are the wooden planks they are using for safety. These are the wooden planks they are using. Okay. This is stalls. Another good image could be this one. Okay, this is not a good resolution image. I'll show you. Let me get a good resolution image. I have to show you this one only because I don't have another good image. Okay, so this is how the structures look like after installments of all the stalls. So these are wooden planks which are keeping the underground intact. Okay, no need to go for all the namings because this is actually for giving you an idea of how this look like. You don't have to draw this in exams. Okay. Then we have square state stopping. So a grid of timber supports square states are constructed as the ore is extracted, providing strong continuous support. Okay, so in this one they actually use vertical stalls, whereas in this one square state stopping they use a complete square shaped, okay, vertical as well as horizontal stops to keep the roofs intact. Okay, just like I've shown you in the previous sketch. All right. So very weak or fractured ores like gold are done by square set stopping. Provides maximum safety in weak rock conditions. Very labor intensive and costly. Okay. So they use square type stops like this one. Complete grid they will make. Okay. They will make like this in here also, bottom also, the top also. They will make repeated things and make a construction like this made up of squares like this. So that it holds the ground as well as the roofs. Okay. Then we have glory hole method. So an open pit to underground transition method where ore is extracted through a large surface crater or glory hole and collected underground. Okay, so it's a transition between open pit to underground transition. So working is ore is mined from the surface crater or glory hole like a simple surface thing, like a, you know, like an open pit mining like this. Okay. Then uh, the gravity causes the broken ore to fall into a vertical shaft or drop point. It is then loaded into cars or conveyors underground. Okay, so they will have it like this. Then from a shaft, they will put it here and they will then remove it and take it to the surface. So it's an open pit to underground transition. This is the ground surface. Okay, so materials which are extracted here will be carried to the underground and then carried by lift or any other, maybe an incline. They can also make an incline like this, from where by use of a truck they can go to the surface, or by lift also they can do that. So uses suitably for steeply dipping massive ore bodies, often used in coals, limestones and metallic ores. Advantages: utilizes gravity, reducing the need for drilling and blasting during loading, and efficient for high production scenarios. Then we have undercut excavation method. So a mining method where a horizontal excavation undercut is made beneath an ore body to facilitate its controlled collapse or breaking. Okay, an undercut is created beneath the ore body either manually or by blasting. This weakens the support, allowing the overlying rock ore to break and fall under gravity. The broken ore is collected from draw points and haulage levels below. This is very similar to the glory hole method. Okay. So here they will do manually or can be blasting also they can do. But in the glory hole method, they avoid blasting. Okay. So uses will be often used in block caving and sublevel caving methods. Caving means they will blast and make caves suitable for massive ore bodies with competent surrounding rocks. Advantages. So block caving will discuss this in caving methods. Don't worry. So allows efficient ore breakage and gravity assisted loading. So this type of things also used in caving methods like block caving, and the other one is sublevel caving is not there. Okay.